Some warships are born to be symbols of an empire's ultimate power. You see them proudly cutting through the oceans, the $13 billion Ford-class supercarriers, or the expensive, heavily armed Aegis destroyers. But there are also ships labeled engineering disgraces. That's the story of the U.S. Navy's Littoral Combat Ship (LCS) program. Its aluminum hull cracked even in normal sea conditions. The gearbox crushed itself to dust on its maiden voyage. Hundreds of millions of dollars worth of weapon modules were scrapped because they were useless. For a decade, this design was the target of expert ridicule and was 3 times called for by Congress. But there's a harsh truth the Pentagon has always understood. The battlefield isn't a design contest. War doesn't award medals for the most elegant blueprints. It simply chose the tool that could solve the equation of life and death. Look at the Strait of Hormuz. This is not an open sea. It's a cramped, deadly cage teeming with invisible naval mines at the bottom and surrounded by swarms of suicide boats and cheap drones in the air. In this geometric trap, sending a massive supercarrier carrying 5,000 lives into it is a suicidal gamble. The giants are forced to retreat to safe waters. So who will the U.S. Navy send to break through that cage? Ironically, the one thrust into the heart of this death zone is the very ship riddled with technical flaws that was once abandoned. Why? In the deadliest environment on the planet, does the symbol of power have to yield the stage to the underdog? How can a fractured foundation suddenly transform into a nightmare that shatters Iran's sophisticated defense matrix? Today, we won't be trying to whitewash a failed project. We're here to dissect a brutal problem of military strategy, to prove that sometimes what saves an entire situation is the most flawed piece of the puzzle. Welcome to Naval Trace. The decoding of the transformation of the failure begins. We're judging why the Pentagon would bet on a technically flawed warship. To understand the nature of the cage they're about to enter. Beat the enemy, you must understand the battlefield. In the Persian Gulf, battlefield itself, weapon. Strait of Hormuz is often portrayed in the media as a waterway ultimately 21 nautical miles, 8 kilometers wide. Number creates an illusion of space. For a U.S. commander, deadly lie. Reality, safe shipping lane with sufficient depth for tankers and massive warships to navigate narrow to just 2 nautical miles in direction. Imagine steering a 100,000-ton war machine through a passage so narrow, see the enemy's cliffs with the naked eye. 10% of the world's crude oil has to squeeze through a pinhole. No space to disperse the fleet. Room for spectacular maneuvers. Traveling on a predetermined track. That's just dimensional space. The threat lies in the 3rd dimension. Persian Gulf is an extremely shallow body of water. Average depth of only about meters. Like a giant water basin. U.S. supercarrier has a draft of about 11 meters. Means the hull of this billion-dollar machine is only 9 meters from the seabed. Cramped space. The carrier completely loses its 3-dimensional maneuverability and turns sharply and reverse sharply to avoid a magnetically induced mine hanging in wait the mud. Forced to go straight through the minefield, hoping its scanning system has everything. Geography doesn't just confine these colossal machines underwater, so blinds them in the sky. Unparalleled power of American destroyers lies in their Aegis radar system, full of seeing hundreds of miles across the open sea. Hormuz line too close. Our waves are reflected by the mountain ranges and rugged terrain of the land, a phenomenon called radar clutter. Iranian anti-ship missile system fires from a coastal mountainside. When the missile escapes the radar jamming, it hits the American warship, measured in tens of seconds. Advantage of early warning is completely neutralized. Surge power action time. Thing is compressed into a suffocating space. Hormuz. Geography is not simply the setting for a military confrontation. Geography is Iran's line of defense. Most potent weapon transforms the enormous size of the American warship from a symbol of power into an undeniable burden. Right behind that geographical wall, Iran has a matrix to welcome those who dare to step inside. If geography is a wall, then behind that wall lies a killing machine refined over 40 years. The Pentagon calls it A2, AD, Anti-Access and Access Control System. But Iran didn't design it like a conventional army. They designed it like a multi-variable problem, forcing the enemy into a matrix where every choice leads to losses. This machine operates on 3 superimposed layers of space. The bottom layer is deadly silence. Thousands of naval mines, from classic contact mines to M52 magnetic induction mines. Hidden among them are Gaudier-class mini-submarines. Their small size allows them to lie dormant in the mud, invisible to American deep-scanning sonar systems, waiting for a hull to pass by. The surface layer is organized chaos. More than 1,500 fiberglass fast attack craft FACs of the Islamic Revolutionary Guard Corps. They don't operate in traditional column formations. They employ a swarming tactic, maneuvering at 50 knots, carrying anti-ship missiles and rockets. The airspace is a hell of interference. Hundreds of cheap, sluggish drones fly alongside decoys interspersed with actual ballistic and cruise missiles. The terrifying aspect of this architecture doesn't lie in the power of individual weapons. It lies in the art of saturation. Let's do a basic calculation. An Arleigh Burke-class destroyer, the symbol of American air defense, carries approximately 90 vertical launch systems, VLS. It can intercept 90 threats before running out of ammunition and becoming a useless target. Therefore, Iran doesn't launch 50 missiles. They launch 150 targets simultaneously. They don't need all of them to be lethal weapons. Just a swarm of plastic drones emitting radar signals like a missile would steal the attention of the Aegis system. Iran's goal wasn't to destroy the ship's armor immediately, but to overwhelm the combat system's processing memory, forcing computers and humans to make the decision to fire expendable projectiles at junk targets. And this is the most crucial point, the one that reshapes the entire concept of modern warfare, the mathematical equation of cost. Every time a U.S. officer presses the fire button to defend a ship, an SM-6 interceptor missile leaves its launch pad. That missile costs $5 million. And what it just ripped through the sky was a suicide drone worth $35,000 less than the price of a used car. Iran has built a toll station at sea, where they forced the U.S. Navy to pay millions of dollars for each pass. In this war of attrition, it doesn't matter how advanced your technology is. Whoever runs out of ammunition and money on the tactical scale first will lose. Confined by narrow space, blinded by terrain interference, overwhelmed by the sheer number of targets, and bleeding financially by cheap weapons, the giants of the U.S. Navy suddenly realized they were trapped. And when even the greatest weapons proved ineffective, the Pentagon was forced to seek an alternative solution. In the conventional U.S. Navy operational thinking, when a crisis erupts anywhere in the world, the president's first question is always, where is the nearest aircraft carrier? But in the Strait of Hormuz, the presence of these colossal machines creates a bitter strategic paradox. The greater the power, the greater the physical burden and political risk. A supercarrier is not simply a warship. It is a mobile piece of American territory. It carries 5,000 lives, costs $15 million in operating expenses per day, and is worth up to $13 billion. To send this symbol of ultimate power deep into shallow waters where a few $1,000 mine or a speedboat loaded with explosives could tear through the hull is not an act of courage. It is an absurd geopolitical gamble that the Pentagon should never allow itself to play. The giants are forced to retreat, anchoring in safe, deep waters outside the Gulf of Oman, staring into an inescapable cage. If the aircraft carriers remain out of the picture, the responsibility falls on the destroyers and cruisers equipped with the Aegis defense system. These are the heavily armed watchdogs. However, pushing them to the forefront runs into the cost equation we just discussed. Sending a $2 billion Arleigh Burke deep into the range of shore-based missiles and swarms of suicide drones solely to act as a tank and clear the way is an extreme waste of resources. When the multi-million-dollar VLS launchers run out of interceptor ammunition, that powerful vessel will instantly become a rubber-coated steel target. Here, the U.S. Navy faces a fatal mission gap. To break Iran's A2AD matrix, they absolutely must reach inside the dead zone and solve two problems simultaneously. First, they need a forward platform close enough to shore to launch a barrage of inexpensive drones inland, disrupting radar, thinning enemy air defenses, and creating openings for decisive strikes. Second, they need a platform to clear underwater minefields and open up global shipping lanes. The harsh reality on the operational map is, no traditional U.S. warship can effectively perform both tasks at close range without risking being vaporized. You don't use diamond gloves to reach into an anthill. The U.S. Navy needs something else. A smaller platform, faster, flexible enough to carry advanced unmanned systems, and most importantly, it had to be a machine cheap enough, flawed enough that America could expendable to lose. And so, all eyes on the strategic chessboard suddenly turned to the platform once considered a technological disgrace, the Littoral combat ship program. But before gambling everything on it, the Pentagon had to do one thing: shed the illusions of a perfect design and confront the very nature of its failure. Transform a failed design into a strategic weapon. Pentagon must first swallow its pride and confront the worst flaws of the Littoral combat ship project. We cannot whitewash this program because its technical failures are real. They are extremely disastrous. Look at the Freedom class LCS-1 variant. Its heart was a combined propulsion system, channeling power from diesel engines and gas turbines into a single gearbox. The engineers misjudged the torque. Enormous pressure crushed the gears into powder as the ship was cutting through the waves. Numerous Freedom class ships were forced ashore due to self-destruction of their propulsion systems. Moving on to the Independence class LCS-2 variant. Optimize weight and achieve high speed. Entire hull was cast from aluminum alloy. Aluminum is lightweight. It suffers from metal fatigue. Under the constant pressure of the ocean's surging waves, ship's structure began to tear itself apart. Structural cracks spread in high-load areas. The warship was already damaging itself before it even went into battle. And the biggest disaster wasn't in the hull, in the operating philosophy. Plug-and-play mission module concept. Initial idea sounded like magic. Single hull, with just 48 hours in port to replace equipment containers, it could transform into an anti-submarine warfare ship, minesweeper, or a surface warship. Pentagon wanted to build a Swiss knife. See, they forgot an immutable principle of engineering. You try to create a machine that can do everything, won't do anything well. Modules were too complex, constantly delayed, over budget, and inefficient. Concept of the perfect multi-purpose ship officially failed. It was at this darkest moment the Pentagon abandoned its multi-purpose ambitions and a miracle of reverse thinking emerged. You strip away the failed weapon modules and complex engineering illusions from the Independence class. What remains isn't a pile of junk. What remains is invaluable space. Specifically, it's a vast, unobstructed flight deck spanning over 11,000 square feet, the size of 3 tennis courts. Traditional naval design, such wasted space would be a crime. In the new era, this is golden land. U.S. Navy realized it didn't need the LCS to be a missile-laden destroyer. It needed to view it through a new lens. It wasn't a direct combat platform. It was a specialized node, high-speed surface truck, possessing a massive space to carry, connect, and launch the latest generation of weapon systems created by the defense industry. Failure of the original systems has paved the way for a far more dangerous combat structure. Fractured LCS no longer needs to try to be a superhero. It is ready to become a mothership in the shadows, and Hormuz is the perfect stage for this transformation. The Pentagon realized that the Independence LCS-2 variant possessed 3 vital characteristics that perfectly matched the Hormuz trap. First, risk tolerance. An LCS costs approximately $3 billion. Losing it would be a major blow, but it wouldn't cripple the fleet like a $13 billion supercarrier. Its tolerance to loss made it a pawn willing to charge straight into a hornet's nest. Second, survival geometry. While aluminum hulls can crack, the Trimaran architecture provides an almost unbelievable level of stability. When a destroyer rolls 8 to 10 degrees in rough seas, the LCS rolls less than 3 degrees. With a ship using a massive 11,000 square foot deck as a drone launch pad, this absolute stillness is crucial for accurate firing of the launchers. Third, speed of opportunity. Speeds exceeding 40 knots over 74 kilometers per hour made the LCS the perfect maneuvering platform. It darted into narrow gaps, unleashed swarms of drones, deployed mine-clearing robots, and then instantly accelerated out of range of enemy coastal artillery in the blink of an eye. No engineer ever intentionally designed the LCS for the Hormuz environment, but by a twist of history, the fragments of a failed project fit perfectly into the most brutal tactical gap in the U.S. Navy. And from that empty deck, a new era of warfare began. From that vast and stable deck, the U.S. Navy began rewriting its combat doctrine. In this new era, a warship is no longer defined by how big its guns are or how far its missiles fly. A warship is now a data hub and launch platform for autonomous weapon systems. And the bullet of this era is called Lucas. This is a historical irony. American engineers dissected Iran's Shahed suicide drone design, retaining the inexpensive but effective aerodynamic principles, and replaced its internals with American technology. Lucas doesn't use noisy engines. It's equipped with ultra-quiet two-stroke engines, minimizing sound and heat emissions. It doesn't fly blindly along a predetermined path. It connects to Starlink satellites to receive commands to cross the horizon. And most importantly, it possesses swarm logic, intelligence. Imagine an LCS carrying dozens of Lucas missiles. When launched, they form an autonomous aerial predator network. If one is shot down, the others automatically reallocate targets. It is here that the much-criticized LCS has executed a classic hoist-by-your-own-petard tactic. The US is using this very same cheap swarm tactic to force Iranian air defenses to fire expensive missiles. The transformation is complete. The Littoral combat ship has now become the pocket carrier of the unmanned era, completely reversing the cost equation the adversary had painstakingly devised. At this point, an inevitable question arises in the minds of critical-minded viewers. Was this seemingly perfect two-tiered air-sea operation a historical fact declassified by the Pentagon, or merely a hypothetical scenario on a tactical board? To maintain the integrity of a strategic analysis, we must establish a clear boundary. First, the technological foundations we have just dissected are entirely real. The ultra-stable hull of the Independence variant's Trimaran, the automated mine-sweeping system, the AMNS ammunition missile network, and the rapid development of inexpensive drone swarms all are present and being rigorously tested by the US Navy for its new combat doctrine. However, what we are dissecting today is not intended to count enemy shipwrecks or to assert an absolute victory with predetermined casualty figures. In the closed world of underwater warfare and electronic warfare, the fog of war rarely allows us to obtain accurate, independent figures immediately. The true value of this story doesn't lie in how many speedboats the LCS shot down exactly. It lies in the logic of warfare. The Hormuz scenario reflects how the US military machine thinks to solve the saturation problem and the cost equation. Regardless of the variables in actual combat, the core principles of physics and mathematics remain unchanged. If you want to unlock a shallow, narrow, and heavily booby-trapped body of water, you can't use a billion-dollar minesweeper. You are forced to combine a mobile, high-capacity platform with a high-risk tolerance with inexpensive, autonomous weapon systems. Taking risk out of human hands and handing it over to robots is no longer science fiction. It is a vital field principle for mastering the seas in the next decade. And that leads us to a final, brutal truth about the fate of the loser LCS. At this point, we need to draw a line to maintain the integrity of this analysis. Is this A2AD network wipe campaign a declassified historical report or merely a simulation? We must pinpoint the facts. All the technologies mentioned are physical facts. The Trimaran's super stable deck, the MCM, mine clearing mechanism that separates humans from the kill zone, and the data-linked, inexpensive suicide drone swarms. All are hardware, shaping the new US Navy doctrine. However, in the closed world of electronic warfare, the fog of war rarely allows the public immediate access to detailed casualty reports. The value of this decoding doesn't lie in counting how many ships the LCS destroyed. Getting bogged down in exaggerating the victory would obscure the strategic nature. We use the Hormuz scenario as a competency test. It reflects core operational logic. To unlock a shallow, narrow body of water densely packed with cheap booby traps, you can't send a billion-dollar supercarrier to mines. You absolutely have to combine a high-risk platform with unmanned systems. The enemy can conceal damage, but they can't bend the laws of cost mathematics and spatial geometry. That's the vital field principle that leads us to the final verdict on the fate of the LCS. The enemy spent 40 years building an impenetrable A2AD fortress, meticulously crafting every mine and missile launcher just to bury America's colossal super battleships. But they never imagined that what would shatter that matrix would be a cracked aluminum-hulled vessel the very Americans had wanted to discard, carrying swarms of drones costing only a used car. That is the cruelest irony of military technology. The Hormuz scenario sends a message reshaping the future of naval warfare. Sea power is shifting. It is no longer monopolized by massive steel structures carrying thousands of lives. The new era belongs to distributed operational nodes, smaller, cheaper, more flexible, serving as launch pads for unmanned systems to reverse the cost equation. The LCS program may forever be remembered in history as a project riddled with flaws, but the battlefield is not an exhibition hall to award prizes for the most elegant designs. It's a matter of life and death. And when geographical and technological variables suddenly shift, what was once considered the worst mistake rises to become the only correct answer left on the chessboard.